All right, mathletes, here's a 3.3, simplifying rational expressions. Rational expression is the quotient of two polynomials. Notice that both on the numerators and denominators of these rational expressions, we have polynomials. So we're going to look at simplifying those and doing some operations with them. Okay, so number one mistake that I see with trying to simplify or working with rational functions is students like to cancel things out that they see in the numerator and denominator, and they'll just cross them out like that. Well, to avoid that, we cannot do that because we have addition and subtractions here of this. The only time we can cancel things out is if they're factored. So to avoid this number one mistake is factor first. Okay, so if we go ahead and factor first, okay, we can see the numerator is the difference of squares. So we're going to get x minus 1 times the quantity x plus 1. Denominator, we can factor into the quantity of x minus 3 and an x plus 1. At this point, because things are being multiplied, we can think of them as something that's being divided by itself is equivalent to 1. And 1 times anything is itself, so in theory it's canceling things out. So what we're left with is x minus 1 over x minus 3. Okay, so to avoid those common mistakes, make sure we factor first. All right, first thing we're going to do is just simplify rational expressions and try and identify those one terms so that we can simplify it. So factor first, numerator, GCF is a 2, so I'm left with an x minus 4 over, factoring the denominator, I'm going to have a x minus 4 and an x plus 3. At this point, I identify that x minus 4 is on the numerator and denominator, something divided by itself is 1. So what am I left with is 2 over the quantity x plus 3. Okay, on part B here, again, factor when possible. Numerator is difference of cubes. I can think of this as x cubed minus 2 cubed. And using my formula of difference of cubes, I'm going to get an x minus 2 times the quantity of x squared plus 2x plus 4. Or 2 squared, over, again, greatest common factor of the denominator is going to be an x squared, and I'm left with an x minus 2. Okay, I'm going to recognize I have something divided by itself, so that's equivalent to 1. They cancel out, and I'm left with x squared plus 2x plus 4 over x squared. And that's going to be as simplified as I can get there. I cannot cancel away my x squared because I have addition and subtraction signs there. All right, example number 2. Here we're going to do multiplication and division of rational functions. And again, with our other ones, we want to factor things first and see if we can simplify them out. So x squared minus 2x plus 1, we can factor this into x minus 1 times x minus 1 over, factor out an x, and I'm left with x squared plus 1. The second term I'm going to multiply, and I can write this all under the same fraction bar because we're just multiplying these out. So greatest common factor is a 4 times x squared plus 1 over, the denominator can be factored into an x plus 2 and an x minus 1. So things that are the same, x squared plus 1 and an x squared plus 1 there, that's going to simplify to 1. Okay, an x minus 1 and an x minus 1 are going to simplify there. So then what do I have left? I like to put my constants first, so I get 4 times the quantity of x minus 1 over x times x plus 2. That's as simplified as I can get, and my final answer of that multiplication. Okay, with division it's very similar, but we're going to remember our rule that dividing by something is the same thing as multiplying by a reciprocal. So we need to flip the second fraction. So I'm going to do this as x plus 3. Now the denominator can be factored as difference of squares, so it's x minus 2 and x plus 2. And dividing, I'm going to multiply and go ahead and flip my signs here. So x cubed minus 8 is going to be now in my numerator. And I'm going to get x squared minus x minus 12 here. And then again, I'm going to factor. These are going to stay the same. Okay, x cubed minus 8 is again a difference of cubes. So same one as I had before. So it's going to be x minus 2 times x squared plus 2x plus 4. And then x squared minus x minus 12. Again, we saw this earlier. This is x minus 4 times the quantity of x plus 3. So as I look for things that are going to simplify, x plus 1 over x plus 1 is 1. That's going to go away. On x minus 2 and an x minus 2 are going to go away. So what I'm left with here is this x squared plus 2x plus 4. Recognize that this can't be factored because if I try and factor it, things that multiply to 4 that add to 2, I'm not going to find any numbers that work for that. So x squared plus 2x over 4 or plus 4 is going to be over x plus 2 times the quantity x minus 4. And that's going to be as simplified as we can get it after we've done that division. Okay, last step here is adding and subtracting our rational polynomials, rational functions. Okay, so first rule we need to remember with fractions is if we want to add them, you must have a common denominator. Well, we're in luck. Same denominator here. So if we're in the same denominator, we just add the numerator. So we get 2x squared plus x, and a minus 4 and a plus 3 is going to be a minus 1. So I just collected like terms there. This is left as 2x plus 5 in the denominator. Well, I need to factor out my numerator. So I'm going to see that I get negative 2 and 1. So that is going to force things to be a 2 and a negative 1. So as I factor out my numerator, I'm going to get 2x squared plus 2x minus x minus 1 over here, 2x plus 5. And as I factor out a 2 and an x, I get a x plus 1. Factor out a negative 1 there, and I get an x plus 1. 2x plus 5. And as I simplify this out, I get the factors 2x minus 1 times x plus 1 over 2x plus 5. I no longer can simplify any more there. I don't have any common factors, but that's adding those two terms. Okay, so now I want to do a subtraction. So now for my subtraction, just like addition, I need a common denominator. So I'm going to use this trick we used before, just multiplying each term by a 1. But I got to be smart about the one I choose. So I'm going to take the denominator over here, and I'm going to multiply by a form of 1, and it's going to be x squared minus 4 times x squared minus 4. So again, I'm just multiplying that term by 1, and over here, I'm going to multiply this by x over x again. That is just 1. Okay? So by doing this, I should get a common denominator. So on the left side, I get x times x squared. I'm going to get x cubed. Denominator is going to be remembering to double distribute across here. So I get x cubed minus 4x. Okay, and then I'm going to subtract, and I'm going to have to remember that it's minus this entire quantity, which is x squared minus 4 over, distribute my x, and I get x cubed minus 4x. Now that I have a common denominator, I can collect like terms in the numerator, so I have x cubed minus the quantity, so this negative is going to be distributed through, so minus x squared, and a minus negative 4 is going to change it to a plus 4 over, and I recognize I can factor out an x here, and I'm going to get a x times an x squared minus 4. Okay. Well, I don't notice that I can factor anything in the numerator, and I'm just going to leave the denominator as such. I could factor it out and say that this is x times x minus 2 times x plus 2. Okay. If I tried to factor by grouping or anything, I would get factor out a x from the first two, or an x squared from the first two terms. Okay, and then that's going to be times x minus 1, and then a plus 4. Because I have an addition and subtraction there, I can't cancel out any x's. I'm just going to leave this as my simplified form. That concludes our notes for tonight. Make sure you highlight any questions you might have and bring up to our next class period. Thanks a lot.